For decades, MTE Corporation has been the industry leader in providing simple, robust harmonic mitigation and motor protection solutions, as well as power conversion equipment. Our innovative designs are known worldwide, and our level of service and expertise is unmatched. Over the next few minutes, with the use of our Power Quality Demonstration Unit, we will show in real time how MTE products positively impact power quality. First, we'll run the system with power going directly to the motor so that we can see what the current and voltage waveforms look like. The voltage waveform is on the bottom in blue, and the current waveform is on the top in green. As we increase the load, the well-defined sinusoidal waveforms indicate that we have good power quality in both. But there are several downfalls to this type of application, mainly a lack of efficiency. When a motor receives power directly from the power source, it's continuously running at its top speed. The motor uses the energy it needs, and the rest is wasted. Adding a variable frequency drive, or VFD, to control motor speed can regulate energy consumption and decrease wear and tear on equipment. Although it adds efficiency, a VFD creates power quality issues on both the input and output sides of the drive. We'll explore the input side first and see what happens when we introduce a VFD to our system. We see right away that the current waveform has been impacted. It is no longer a sine wave, but instead takes on a double hump form that is characteristic of VFDs. This is an indication of harmonics on the system. As we add to the load, the double hump waveform increases in magnitude, as does the level of harmonics. Looking closely, we can see that between the humps, the current drops to zero, and the top of the humps grow taller. This is an indication that our current distortion is high. A typical VFD application can contain harmonics of 85% or more. That level of harmonics is not ideal because they create alterations in the voltage waveform, which leads to unwanted problems with the connected equipment. High levels of harmonics often result in overheating and malfunctions in transformers, motors, and wiring. They can also induce nuisance tripping, inaccurate instrumentation measurements, and higher energy costs due to poor power factor. In order to bring these harmonics down to an acceptable level, we can introduce MTE's RL Reactor at the input side of the VFD. The RL Reactor is a very robust product that offers 150% continuous overload capability with low watt loss. This same reactor can also be used on the output side of the drive without any derating. As we bring the RL Reactor online, we can immediately see the effect it has on the current distortion by the reduction in intensity of the current spikes. As we increase the load to 75%, the current is no longer discontinuous. It is not a perfect sine wave yet, but we've taken a big step in reducing the harmonic distortion. An RL reactor can typically reduce harmonics to around 30%. We've already reviewed how a standard VFD application can create 85% or more of harmonic content, and that an RL reactor can reduce that level to around 30%. But if we want to significantly reduce harmonics or meet IEEE Standard 519, we can introduce a Matrix AP harmonic filter. Let's start the Matrix AP with everything running at 100% load. We can see that the current waveform is relatively sinusoidal, representing a significant improvement to our power quality. The harmonics would now be at 5% or less, which will comply with the IEEE Standard 519. With the Matrix AP, the overall system will experience better performance without the risk of utility penalties. However, this is at 100% load. Since VFDs allow varying motor speeds, systems using them rarely run at full load. Unlike other filters, the Matrix AP's patented adaptive passive technology utilizes a revolutionary reactor core that allows it to adapt its impedance in response to changing loads. The result is consistent, low harmonic performance over a wide load range. The technology also delivers a filter with low capacitance, meaning it has a low leading power factor and can be used in generator applications. Let's see the AP technology in action. As we decrease the load to about 75%, you can see that the current waveform is nearly unchanged. In reality, we typically see a 5% harmonic level with the matrix AP down to a load of 50% or less. Even as the load reaches 30%, we are still showing a relatively strong current waveform. MTE actually guarantees an 8% current distortion level to a 30% load. Let's recap the differences in harmonic distortion for the VFD without protection, the VFD with an RL line reactor, and the VFD with a matrix AP harmonic filter. It's clear that adding these MTE products at the input side of a VFD will reduce harmonics and help extend the life of equipment. Now that we've seen the effects that a VFD can have on the input side, let's turn our attention to the output side of the drive. Here, we must understand that the drive does not transmit a clean sinusoidal waveform, but rather a series of pulses called a pulse width modulated signal, or PWM, out to the motor. Unfortunately, those pulses, when combined with long lead lengths, can result in voltage spikes at the motor, causing winding insulation breakdown, loss of efficiency, overheating, and bearing damage. Inside our demonstration unit, we have the capability of running 250, 500, or 1,000 feet of cable between the drive and motor. For the purpose of comparing MTE's motor protection solutions, we will run the system with 1,000 feet of cable and see what happens. As we bring the VFD online, we notice right away that the voltage waveform is severely distorted. In fact, we're pushing about 1400 volts out to the motor and getting dangerously close to the peak insulation voltage rating of the motor. As we zoom in, we can also see that we are experiencing reflected voltage waves, or ringing, that when combined with the output voltage may result in pulsing over the voltage rating of the motor several times within one PWM cycle. These factors can greatly reduce the life of the motor. Our first line of defense is to add MTE's RL reactor between the VFD and motor. Due to its unique design, the same RL reactor we used on the input side can also be used here on the output side without any derating. For optimal performance, the RL reactor should be used for cable links up to 300 feet. With the RL reactor now connected, we can see a dramatically different wave shape. We have brought the peak voltage down considerably from 1400 volts to 1000 volts. And as we zoom in, we see that the rise times have also improved. Both of these reduce the stress on the motor's winding insulation and ultimately extends the motor's life. We've seen what can be done by adding a simple reactor into the system. But if we want to go a step further, we can add a DV Sentry DV-DT filter. With its patented design, the DV Sentry provides common mode reduction, peak voltage protection, and improved rise times all in one unit out to 1,000 feet of cable. As we switch in the DV Sentry and start the system, we notice our peak voltage has now been reduced from 1400 volts to around 900 volts. This is critical for non-inverter duty motors that are designed with a maximum peak voltage of 1000 volts. Now, as we zoom in, we see the ringing that we previously saw is gone. We have a nice, smooth waveform with maybe one overshoot and then damped out. The DV Sentry provides great motor protection against peak voltage, but will also attenuate the common mode current by over 50%. These are all great, but what if we need protection beyond 1,000 feet? MTE's Sine Wave Guardian filter allows us to run a motor at any cable length up to 15,000 feet. It is the best solution on the market today for motor protection in that it cleans PWM waveforms generated from the drive by virtually eliminating high-frequency content and voltage peaks, as well as reducing motor heat to give customers extended motor life and less downtime. It's more efficient, tolerates higher ambient temperatures, and doesn't require VFD cables, making it ideal for a variety of applications from steel mills to oil fields. With the Sine Wave Guardian now enabled, we can see it has taken the output PWM signal and turned it into a nice-looking sine wave. But wait, there's more! Let's run the system again with no filter. Do you hear that loud screeching noise coming from the motor? As we increase the speed, we can hear it intensify. In critical applications, such as an HVAC system where noise might become an issue, adding the Sine Wave Guardian filter goes a long way in making the system run quieter. when we add the sine wave Guardian back into the system with the same set of parameters, both the pulse width modulation and screeching noise virtually disappear. As we have just seen, MTE offers a variety of motor protection solutions to reduce peak voltage, improve rise times, or simply extend the life of your motor. The RL Reactor is your choice for cable lengths up to 300 feet. For cable lengths out to 1,000 feet, the DV Sentry is the perfect solution. The best-in-class sine wave Guardian has you covered out to 15,000 feet. Thank you for watching our demo video. We enjoyed sharing our knowledge and expertise with you. If you'd like to learn more about MTE Corporation and what we offer, please visit our website at mtecorp.com.